Okay, class, today we're going to talk about classifying numbers. Okay, so let's dive right into it. There are several sets of numbers that we have to be familiar with. And in your class, we have to be familiar with the first four sets. So we have to be familiar with what is a natural number, what is a whole number, what is an integer, and what is a rational number. Okay, so those are the ones that we have to be familiar with. I don't know why it's not. Okay, so those are the ones that we have to know. So in this lesson, that's what we're going to talk about. Okay, so first let's talk about natural numbers. Natural numbers are also known as counting numbers. So they're the ones that we carry on our fingers. Okay, and the first number that we count with is 1. Like 1, 2, 3, 4, and so on. Those are our natural numbers, and they continue all the way out to positive infinity. So 1, 2, 3, 4, 5, 6, and so on and so forth. Now there's one number that hopefully you see is missing there. Okay, because natural numbers are just the numbers used for counting. And the number that's missing is the 0. Okay, so if we were to go to the next set of numbers, we would find out that we have what we call whole numbers. And whole numbers are all the natural numbers, or all the counting numbers, plus 0. Okay, so if you'll look at the picture here, natural numbers are 1, 2, 3, 4, and so on. Well, the whole numbers, we have all of those numbers, but we also include the number 0. Okay, that's the big difference between those sets of numbers. Well, the third set of numbers that we have to deal with is what we call the integers. So we've got the 1, 2, 3, and so on with natural numbers. We've added a 0 with the whole numbers. Well, integers are all the whole numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. And their opposites, which we call the negative numbers. Negative 1, negative 2, negative 3, and so on all the way down. So integers are whole numbers and their opposites. Well, what makes a number opposite? Well, when we start talking about opposites, we're talking about the distance a number is from 0. Okay, so if you were to look at this number line here, here's our 0. Okay, there's our 0. So if we were to look at number 3, or look at 3 right there, 3, positive 3 is 3 spaces to the right of 0. Well, 3's opposite is 3 spaces to the left of 0, or negative 3. So when we talk about opposites, we're talking about the distance a number is from 0. It's very important. Okay, and typically opposites are going to have the same absolute value, okay, which means the same distance away from 0. Okay, so we've had 3 sets of numbers so far. Natural numbers are counting numbers. Whole numbers, add a 0. Integers, we add the entire set of negatives all the way out. So all the whole numbers plus the integer. We've got one more set of numbers to talk about, and that is rational numbers. And rational numbers, okay, this one's a big. You'll notice that rational numbers include all the integers, the whole numbers, the natural numbers, includes them all. Now, when we look at that number line that we just saw, there was one thing missing that I see missing, and that's all these numbers that are in between 0 and 1, or in between 1 and 2. And those are the numbers that we call rational numbers. So a rational number is any number that can be expressed as the quotient or fraction p over q of 2 integers with the denominator q not equal to 0. What that basically means is that it's any number that you can write as a fraction. Any number that you can write as a fraction. So here's some examples. 1/2 is a rational number because it's 1 divided by 2. It's written as a fraction. 0.75 is a rational number because it can be written as 3/4. 1 is even a rational number because it can be written as 1 over 1. 2 is rational because it's 2 over 1. 2.12 is a rational number because it's 212 over 100. Okay, or 2 and 12 100ths. Even negative 6.6 can be written as a fraction, as negative 66 over 10. So any number that can be written as a fraction is a rational number. So let's see if we can go through a few examples. Okay, here's an example. Okay, we've got the number 7. What I want you to do is choose all possible things that 7 can be a part of. Okay, is it a natural number? Yes, it is. It is what we call a counting number. Is it a whole number? Yes, it is. There are no fraction or decimal parts. Is it an integer? Yes, because it's part of the whole number set. Okay. And is it rational? Could I write it as a fraction? Yes, I could write it as 7 over 1. So that belongs to all three sets. What about 4 over 5? Is it a natural number? Is it counting? No, it's not. What about a whole number? No, it's not, because it's a fraction. So it's not. What about an integer? Well, for integers, it has to either be a whole number and its opposite. Okay, and since it's not a whole number, it's not an integer. Is it a rational number? Yes, because it can be written as a fraction, because it is a fraction. What about negative 18? Well, negative 18 is it natural? Is it a normal counting number? No, it's not. Is it a whole number? No, because it's got to be from 0 to positive infinity. 0, 1, 2, 3, and it's not, so it's not a whole number. What about an integer? Could it be an integer? Yes, because it is an opposite of a whole number. So it is an integer, which means it's also a rational number. What about 0? Is 0 a natural number? No, it's not a natural number because 0 is not a counting number. What about a whole number? Yes, it is a whole number. What about an integer? Yes, because integers are whole numbers and they're opposites. What about a rational? Yes, it is, because you could have 0 over 1 and it still has a value of 0. Okay. What about 21.7? Is it a natural number? Is it a counting number? No, because it has a decimal part. Whole number? No, because it has a decimal part. Integer? No, because it has a decimal part. Rational number? Yes, because it can be written as a fraction. What about negative 9/10? Is it a natural number? No, not a natural number. What about a whole number? No, not a whole number because it's got a fractional part. What about an integer? No. You may think it's an integer because it's got a negative, but that's not the case. Okay? You can have negative numbers that are not integers because they are rational numbers. Remember, an integer has to be a whole number or an opposite. Cannot have a fractional part. What about 12? Is it a natural number? Yes, it is. What about a whole number? Yes, it is. What about an integer? Yes, it is. What about a rational? Yes, it is. Okay. What about negative 12 then? Is it natural? It's not a counting number, so no. What about a whole number? No. Okay. What about an integer? Yes, because it is one of the opposites of a whole number. Okay, what about a rational? Yes, because I can write it as a fraction. And now for the last one. This is kind of the tricky one. 15 over 3. Is it a natural number? Yes, it is. Because 15 divided by 3 is equal to 5. So that's the thing that we have to use. We've got to use the fraction simplified form to determine what set it belongs to. So is it a whole number? Yes. Is it an integer? Yes. Is it a rational number? Yes. So what we've talked about today is number sets. And the ones that we have to learn are natural numbers, which are normal counting numbers, 1, 2, 3, 4, and so on. Whole numbers, which add the number 0. Integers, which add all the negative numbers that go along with it, plus the whole numbers. And then we've got rational numbers, which is any number that can be written as a fraction. So those are the sets that we've got to know in 7th grade. Until next time.